Okay, so what am I going to talk about? Today, I'm hoping to cover most of this. You know, we'll go as fast as we can. I don't think we'll get too much faster than that. The goal is to try to do things in a somewhat mixed fashion. You know, basics of Python. How do you program in Python? What are the basic statements you'll need? Then go on and learn how to make Python useful. Okay, how do you do graphics? How do you work with epics? Once that's done, we'll come back and this might be next month, talk about how you do object-oriented programming, for example, because you really need to understand that before you start working with graphical user interfaces. And besides, it's the better way to program anyway. We'll see how far we get. I mean, one of the things I'd like to talk about is, for example, using MySQL, because I think that MySQL or other database engines are really underutilized, particularly for data collection. All right, so where to go for information on Python? There are two basic books here that are referenced, which have the nice advantage that they're available on the web as well for free. All these notes will go up on the web. As a matter of fact, I think they already are. They already are on the web. Quick question, actually, as an aside: how many people here are on the Python interest group mailing list? Okay. How many people are not and want to change that? Okay. Debbie Kwok is the person to get in touch with, but if you send an email message to me, my last name's a little easier to spell, but not by much. I'll forward it to Debbie and get you on the mailing list. Let's see. This is also a pretty good book. I'll talk about what the difference between Python 3 and what we're going to cover here is a little bit further on. There are some minor differences, but it's not a bad place to go. This website, Software Carpentry, was recommended to me. It has lots of examples on it. It also has recorded lectures, sort of like what I'm hoping to do with this stuff. The Python website has tutorials on it. And the Python website also has very good documentation, but I will comment that, at least for me, the documentation for the language itself is pretty useless, because it describes it in very technical specifications. So I go there for a description of all the libraries and a lot of other stuff, but I don't go there to try to understand how the syntax of the language. Okay, so why Python? Well, I would say that Python, first of all, Python is a scripting language. It's a little different from, let's say, if you've programmed in C or Fortran or something like that. In those languages, you need to write your code, send it into a compiler, and then test it. In Python, the language is basically interpreted as it's seen, and that means that if you want to, you can sit down at a command line and type in the language and commands and see what it does. It's also a very rich language. It has lots of functionality for doing lots of different things, and that turns into speed, because matter of fact, I'll show you some really short programs that do a lot of stuff. And if you can do things with a small number of lines of code, you can do it fast, typically. These are reasons why, if I have a choice, I would rather program in a scripting language than anything else. The disadvantage of a scripting language is that it can be, it doesn't have to be, but it can be a lot slower. If that turns out to be a problem for your particular application, then you might find that there's a particular section of the code that you need to go out and write in another language like Fortran or C, where you get more speed, but it's relatively easy to do that if you need it. Okay, the Python is free. You can get the source code and compile it yourself even if you want to. And it contains lots of very nice packages, and we'll talk about some of those. The disadvantage is that it's not easy to get Python with all the packages that you want. So let me just give you some quick demonstrations. Here is a 9-line program to display a Bessel function. The first 3 lines of this, and you don't have to worry about the details of it, bring in the libraries that we're going to need. The next 3 lines do the calculation that we want, and then finally 3 lines to do a contour plot. That's pretty compact. That's pretty simple. And it's sort of fun. I have another version of this program that does plotting. Let's see, in a different platform, and to bring this one up, this file, which I'll show you in a moment, is exactly the same as the previous one, but I changed the last 3 lines, and not even all that big that much. And now you can see the same thing plotted in OpenGL, so you can see the data structure as a 3-dimensional image. So why do I like Python? Well, Python allows me to do stuff like that pretty easily. So here's the same thing, and all I've done is change these 3 lines to bring in to show the data with a different package. Okay, one gotcha. Python's changing. The people behind the Python language decided that in the 10-15 years since they started the language, they wished they had done a couple things differently. So they decided to do that, to change that. So in release 3.0 of Python, they made a number of changes under the behind the in the way the language is implemented in C, and made a few changes in the syntax of the language. And where we come to things that are different, I'll point them out. It's not a huge difference, and if you make with a very small number of changes, you can take your code from Python 2 to Python 3. The one thing that I will mention is that there's a lot of compatibility between the most recent versions of Python. If you want to know everything that's different, there's a web reference here. If you're going to want to program on the beamlines, if you're going to use the BCDA Python to EPIC's interface, you're stuck with Python 2.5, at least for right now. Python 2.5 is about 6 years old, so that was one of the reasons why I decided I would stick with the older version of Python. Okay, and just because, and I should mention, just because Python 3 has been out for a year or a year and a half, doesn't mean that the Python 2 is dead. It's still being updated, and it will probably be updated for another year or two. So both versions of the language are being carried in parallel. And finally, for most people, Python there's actually a routine that will take a Python 2 code and edit it for you to make it compatible with Python 3. So I wouldn't worry too much about this. These are packages that you're likely going to want to use, perhaps this one only on beamline computers. Getting Python with all the bells and whistles is not trivial. There are 2 distributions that are free that I haven't had much chance to work with. This one I have used a little, but it's only available for Windows and Linux, and if preferable for me as I work on the Mac. This one is very good, but it costs about $200 either per user or per computer if the computer is going to be shared. The good news is that AES has just purchased a whole bunch of licenses, and we're going to give the ones that I think the first 50 out for free, and then if we need more, we're going to start back charging the people who got the free ones. But we do have a bunch of licenses, so I hope within a week or so we'll figure out how we can get that out to people. If for the meantime you can download a free demo version, and at some point later they'll come after you and say, are you going to buy it or not? Let's see. Running Python. Okay, you already saw one example where I had a Python script. I just simply typed Python followed by the name of the script, and it ran the script. but it's also possible to just type, and this is done on a beamline computer, APS share bin Python, and here it tells me what version of Python I'm using. This is when it was compiled, and here this prompt right there, those 3 arrows are telling me that it's ready for me to type a Python command. So I type the world's shortest program, which is print hello world. Python then runs that command and it comes back and it prints hello world. Likewise, I could have put that into a file. That's what I did here. And once I've got it in a file, I can run that file, doing the same thing. Turns out there are other ways that you can run Python. If you're going to be doing a lot of Python coding, I suggest that there are some other things you want to look at. One of which is a shell called IPython. IPython is sort of designed as a MATLAB replacement. Okay, where you can work in Python, do Python programming, but do graphics and linear algebra and all that sorts of stuff as easily as you can in MATLAB. You may or may not agree, particularly if you're enamored of MATLAB. There's something called IDLE, named after Eric, and it's a shell that you can run Python in. I don't know that it's really worthwhile these days because there are better products out there. Something that I'm just starting to look into myself, but looks very good, and somebody asked me what my recommendation would be. If you're going to do, you might not do this right away, but if you're going to do any significant level of Python development, I suggest looking into Eclipse and PyDev. And that sets up an environment where you have access to documentation and debugging and stuff like that. So it's a very good environment for developing Python. For those of us who are already using Emacs, you may want to consider coding in Emacs. I wouldn't recommend it if you don't already know it. And another IDE, commercial IDE, that is out there for developing in Python is called, but from a company called Wingware. And I've played around with that a little bit. I haven't done a lot. It has a free version recommended for, that was stripped down for use in classrooms that's also worth considering. What one you're going to choose and so on, that's really a personal choice. But I recommend looking into this one and maybe that one. I use IPython on a regular basis, and we'll see a little bit about what that's for. And it doesn't, no reason not to use it. I just got something. Who gave this to me? Dennis gave this to me yesterday. If you want to play around with Python and you don't mind downloading Microsoft Silverlight, which is a plugin that fits into most web browsers, you can actually do Python in a web browser. You won't be able to do the very sophisticated stuff, but at least in terms of playing with the basic commands. Okay, as you will see, Python is really persnickety about indentation. And the last thing you want to do is worry about that your stuff yourself if you can get a computer to do it for you. So, bit of advice, don't do any significant level of programming in Notepad or WordPad or Microsoft Word or anything like that that doesn't know about Python syntax itself. If you use any of the IDEs I mentioned before, they're fine. There are a bunch of things that have been, if you go to this web page, there are probably 50 or 60 different editors for various platforms discussed by people who know, love, or hate any one of them. So that's where I would go in terms of learning about Python. And if I was starting today, I probably would start with Eclipse and PyDev. All right, a little bit of Python trivia before we get started in looking at the language. Where did Python come from? Guido van Rossum invented this quite a while ago in the Netherlands. He's now got a nice job with Google. Continues to be involved in Python development, although not full-time. But it's nice to know that Google's interested in Python. I believe that YouTube is completely done in Python. Okay, lots of other people are now involved in developing Python. The community has named Guido the benevolent dictator for life. Let's see, what else? If you wonder where the name Python came from, it came from Monty Python. So let's see. All right. So I think that takes us out of this talk. Oh yeah, homework. All right. Figure out which distribution of Python you want to use. If you're on Windows or Linux, you got more choices. Install it or get it installed. It seems like I was able to install it on my own for a single user without having admin privileges, but you might need admin privileges depending on how locked down the computer is. Think also about an IDE, and see, a week from now is about the right time if you have to work through IT. All right. Let's see. Okay, so that's giving you sort of an introduction to what Python's about. Let's take a look at the language itself. Okay, and the first thing you want to learn about with any language is how you save things. How does storage work? And data types. What kinds of data can you store? So let's go jump forward to that. Okay, variables in Python are a little different than variables in other languages. Was there a question there? No. Okay. So, a variable should be thought of as a place to reference some data object. Okay. I won't go through the details here, but the normal rules of naming variables apply in Python, except there's no limit on the maximum length of a variable. I read somewhere on the web where somebody tried to test it out, and the basic result was the length of a variable was limited by the amount of memory they had on their computer. I think it's probably more limited by sanity. Okay. So you associate a value of some sort using the equal sign. And notice that no declaration is needed. Okay? People may think that Python is an untyped language. If you worked in Tcl, everything in Tcl is a string. That's not true. And that's one of the main advantages that Python has over Tcl, is that it is a very strongly typed language. Every piece of information has a type, but variables themselves are not typed. You can put a reference to any data object into any variable. Okay, how do you see what's in a variable? Well, easiest way is print. If you say print followed by something, it will print out what it is. If you're working at an interactive shell, just simply typing the variable will cause its representation to be shown. And this brings us to our first gotcha, and it's probably the biggest one, which is that when come Python version 3, the print statement changes from print followed by a space followed by one or more things that you want to print, and to print as a function where you give it arguments. And that's one of those things that the Python 2 to 3 converter will fix for you. So I'm not worrying too much about that one. Okay. What if you want to know what the type of a variable is? Well, Python will tell you if you ask. So here I've defined 3 variables, a, b, and c, string, a integer, and a float. Python figures that out from itself by looking at them. And if I ask what's the type for a, str, b, int, c, float. Okay, I can define a float, but if I put quotes around it, it's a string. That should be obvious to this audience. You can cast things from one type to another. So if I take this string and I pass it as an argument to float, then it will parse it and turn it into a float. Okay, Another primitive data type that you can find in Python are Boolean types. There are two Boolean values, true and false. The capitalization matters. It has to be capitalized exactly like that. Uppercase first letter and the rest lowercase. Okay. Complex numbers turn out can be written one of two ways. If you want to specify something, you can say 1 plus float plus another float times j. But I would suggest you just get into the habit of calling complex. It's a lot easier to make sense out of. If you need them, Python has some pretty sophisticated types of computations that it'll do for you. There's a package that gives you fixed precision floating point calculations. So if you want to do 20 significant figure calculations and are ready to pay the price for that in terms of speed, it'll do it for you. If you want to work with fractions where 1/3 is exactly 3.3333 ad nauseum, it has a package that will do math as exact fractions. And if you want infinite length integers, 2 to the 32 is not enough. It'll do that too. There's a long integer package. Strings, it's worth mentioning there are a bunch of different ways of specifying strings. You can use double quotes. You can use single quotes. If you want to put quotes within quotes, the easiest way is to use the opposite flavor, but you can also use backslash escaping. If you have a multi-line quote, you want a quote that's going to span several lines, you use 3 quotes, again, of either flavor, and then you just start typing your string or entering your string, and it will continue until you get to the last. You have matching 3 quotes, again, of the same flavor. And this will capture the line feeds. So I have 3 quotes, then a new line, that's the /n there, the new line there, and so on. So that's why I have 1, 2, 3, 4 new lines in there. Yes, John. No. And I believe it only. I'd have to test this, but I believe in Windows it always gives you new lines. That's a good question. I'm not 100% certain on that, but I'm pretty sure that that's correct. If you wanted to create a multi-line character string and you don't want those new lines in there, if Python sees one character string immediately followed by another character string, it just simply concatenates them for you. Turns out you can also concatenate with the plus sign, but we'll get back to that. We'll talk a little bit about this more, but if you we'll talk about tuples, but you can't put commas between there. That makes a different kind of data object. However, you can use a parenthesis to say, you can use parentheses rather freely. So if I want to spread this over multiple lines, I can just, by putting a starting parenthesis here, Python says, okay, you must mean that this line continues until I see a closing parenthesis. So you can't continue a single character string over multiple lines by just putting an open quote, single open quote, and then continuing, because it will hit an error. But this is a way to enter a line that is as long as you want it to be without any carriage returns in it, by just simply having one quote after another on as many lines as you want to use. What else? So here we're going to take a little bit of a look about the object orientation, or the object built in, the way that objects are built into Python. When you define a string, you inherit a whole bunch of routines. This is a list of the routines you might want to use. There's a whole bunch more that you probably shouldn't use directly. And if you want to use one of these, so I've defined a string here, and if I want to access the upper routine that's associated with it, s.upper will call that on the string, and here you can see that it's converted my string to all uppercase letters. Actually, what this has done is it's returned a string with all uppercase letters. That's a new value. S has been unchanged. Capitalized just capitalizes the first letter. Starts with takes an argument. Does the string start with this value? And the answer is yes, so it comes back true. Does the string start with IS? And the answer to that is false. But I can ask it to find IS in the string, and it comes back and it tells me that it occurs in position 2 of the string, where this starts as 0. So this is 0, 1, I is 2. Strings define operations. So here, strings define the override or the plus operation, or define what the plus operation is. So plus on character strings is defined as concatenation. Mary? No. No. This is built in. Yes, John. Right. You'd have to look the documentation on find. There's one way would be you would just simply say S starting at character 3, and then it won't find the first one. But I believe there's also an argument in there. There may even be one. There may even be an argument that will cause it to return all of them. I'm not sure. Okay, one more data type. This is a little weird one. Python defines something called none. Why do you have a type called none? Well, this is in a sense a value that means undefined. Okay, and it's used a bunch of different ways. I don't think it's true actually that in this case, but if IS was not in this string, it might be a really appropriate way to indicate that it's not there by returning none. I believe it returns -1, but in many cases in Python, if you ask for something and it's not there, you get back a value of none. It's also a nice handy way of initializing something that you're going to use later. Notice, by the way, no quotes. None with quotes would be a character string. Okay, conversion with data types. I should have actually put in here what happens if you put in a character string, but you can convert an integer to a float if you want to force it to be a float. You can take a float and make it an integer. You can't take a complex number and cast it as an integer, because that doesn't make sense. But we can take the real component and cast that as an integer. And if you pass one of these things a character string, it will do its best to interpret it. And if it can't, it'll throw an error. All right, so a little bit of homework. So what's the difference between these three variables? Is there a difference here? And following up on John's question, my clairvoyant knew that it was coming, how would you find out more information about the routines associated with the strings? Pause for a second for any questions. Okay, the eyes are still open, so I haven't put anybody to sleep yet. Yes, go ahead, Andrew. Mm-hmm. Yes. Yeah, I won't. What I would do is, I don't have any recommendation against using those. I would just look to see that you're going to have the packages that you're likely to want to use available as well. Because if you find that, let's say, you have Python, you have matplotlib, and you don't have WX, and you're going to want to do GUIs, then at some point down the road, you're going to want to use a package that gives you that. So my experience is that you can do pretty well. Also, it's going to depend on what version of Linux you're using. I don't know what one does to get the latest Pythons with Enterprise Linux. But if you're using, any of the the more modern Fedora Core, Ubuntu, I think Pete Jemian said that if you're using Ubuntu, then there's no reason to get one of those distributions. But if you're asking me, I don't have the experience because I haven't done enough with it. I stopped being a Linux user when I got one of these. Well, except I run them occasionally in parallel, but parallels to test. But okay, Python would be pretty useful if that was all the data types we have. But Python has some really neat data types out there, although they may be a little bit confusing at first. So let's take a look at some of those higher level data types. I accidentally gave you a peek of one of them before. So the three most basic types are lists, tuples, we'll go back to strings a little bit, dicts, and I'll introduce one relatively new data type called sets, which I find very useful, and we'll talk a little bit about length. So a bunch of data types are available. I mentioned that the three basic ones are lists, tuples, and dicts. Lists and tuples are ordered collections of things. What those things are, we'll talk about. Dicts are unordered collections where you have a key and a value. These collections can contain primitives, and the primitives do not need to be of the same type. Every value in a list or every value in a dictionary can be of a different type, and you can nest them. A dictionary can contain another dictionary which can contain another dictionary, or a list can contain a dictionary which can contain a tuple. Any data object can go inside any other data object. All of these things play the roles of what you would do with arrays in C or Fortran. And which one you would choose depends on what you want to do. So let's look at the most basic one, a list. A list contains a bunch of stuff. You make a list, at least one way to make a list, is using square brackets and then a bunch of things separated by commas. You can stick a comma at the end if you want it, or not. You can, once you've made a list, you can address it individually. So element number 2 is the third element, so that's 3. You can go into a list and change it. So I want to change the third element from 3 to -3. So I do that by just addressing it. And now if I print out the list, I see that the third element's changed. And as I said before, a list can contain any other Python data type. So here is a list that contains an integer, a float, a string, another list, and a complex variable. And I've specified the complex variable by its variable name. So as we'll see that matters that I did it that way, but we'll see why. Okay. This is a little complicated. I won't spend a lot of time on it. You'll have it in your notes. You can reference a list not just by specifying a location in the list. You can specify a starting position, an ending position, and an increment. And here I've addressed things a whole bunch of different ways, and you can use that not just to get, so for example, here I've looked for element 1 through up to and not including element 4, and we'll see how to think about that in a moment. Here I'm going from element 4 to the end. Here I'm addressing from the, here's a better example. You can also address from the end. So -1 means is addressing from the backwards end, from the end of the list. I can change things. So here I've taken 3 values, 5, 7, 3, 5, 7, and I've assigned them a 0. So I've now changed 3 values in the middle of my list. You can even specify an increment. So here I've specified that I want to take, well, both of these, take every other element. In this case starting with 1, in this case starting with 0. And I can again use that in my addressing. And I can even have an increment that's -1. -1 will take the list backwards. Somebody in the first class came up with a very reference to something on the web, which is a very nice way to sort this stuff out. Okay? Think about a list, or a string for that matter, as having a bunch of nodes. Node 0 becomes comes before the first entry, node 1 before the second, and so on. And you can use any number for this kind of indexing. So any number greater than 6 will point to this spot here. Likewise, if I want to go from the other end, -1 puts me here, and any number greater than -6 puts me at the beginning. So therefore, if I want the whole list, I can say 0 to 6. I can leave those numbers out. Just putting a colon is exactly the same thing. I can say -6 to 6. That gives me the same thing. And I can say -99 to 99 if I want to. And all of those will give me back my entire list. If I specify a start that comes after my end, and we always go from left to right with a positive increment, then I get nothing. So 0 to 0 gives me nothing. 1 to 0 gives me nothing. 6 to -6 gives me nothing, because they're all, in all cases, the start element is coming after the beginning, the end element. But everything changes if I use a negative increment. The positions of these nodes are relabeled, and now the end has to be before the start, because now we're going in Hebrew. So 4 to 0 with a step of -1 starts me here and goes to there. So I get 7, 5, 3, 2. I can use negative. I can use either the negative index or the positive index. So 6, which brings me to which is past the end. Let's see, how did this work? 6 to -7. One I don't understand actually. I might have grabbed the wrong list when I did that one. I've got to check that one. All right, I won't check now. You also get more routines that come with lists. Comes with an append that sticks an element at the end. You can insert something at an arbitrary place. Here I've put 17 at the beginning. Here's the first weird routine as far as I'm concerned. Sort does not do what you might think, which is to return a sorted list. The reason it doesn't is because it anticipates you might have a very large list, and you might not want to make 2 copies of it, so it doesn't in-place sort. So I've taken my out-of-sequence list, I've sorted it, now A is sorted. You can use lists as either first in, first out, or first in, last out, buffers, using pop. By default, pop pops from the end, but pop can also be made to pop from the beginning. And as we'll go through, if you want to find out how many elements you've got, len will tell you the number of elements. All right, let's see. You don't have to build a list by specifying all the elements the way I did. You can start by defining an empty list. Here's a list with no elements. And then I start putting elements into it. You can't add elements by referencing a part of the list where you don't have a value yet, and just filling it. So this won't work, because there's an element. This gives me element 0. That gives me element 1, but I don't have element 2 yet. And strings, like strings, lists define the plus operation for you, so you can do concatenation. Next list type thing that we're going to look at are tuples. Tuples are just like lists in almost every way, except once you've made a tuple, you can't change it. The term that's used in the documentation for that is immutable. You can define a tuple just by using commas, but it's helpful for people who are looking at your code to see those parentheses. They're optional, though. You again can address individual elements in a tuple just like we did before, but you can't change them. Okay. A tuple, just like a list, can contain any data type. You can define an empty tuple, but you can't add to it. And tuples also concatenate. And it's worth noting that, wait a minute, how can I concatenate two tuples if I can't change them? Well, you're not changing your tuples. Your tuples are remaining intact, but you're making a new one. And the new one is the concatenation of both. Okay, so tuples optionally use parentheses and can't be changed. Lists always use square brackets and can be modified. And there are different data types. You can't, for example, concatenate them. But you can turn a tuple into a list or a list into a tuple. Okay, let's revisit strings. I didn't mention before that strings can be indexed just like lists and tuples. And like tuples, strings can't be changed. You can reference, I've put the alphabet into a variable called ABC. I can look at the second element of ABC, but I can't change it. Okay, and I can even use the indexing that I showed you before. Here I'm looking at every second character starting with Z. I don't know what I'd use that for, but someday I'll find a use for it. Probably not a confusing data type for you folks who've done programming in other languages, but a dictionary is a place where you can store values with a key and a value. So, so here I start by defining an empty dictionary. And then I'm going to define element number 1, or an element that's associated with the integer 1, and give it a value of 1.0. Here I define an element 2, and just to show you that I can define things in any way that I want to, the next element that I define is the key as a character string. And keys can be anything. And a key could be a tuple. That may sound a little crazy, but most of you guys will be able to relate to Bragg indices, to Miller indices. If I wanted to store a table of structure factors, it would make a lot of sense to have a tuple for my HKL value, my 3. So I would have a value associated with 001 as a tuple, or 111 as a tuple. And that value could be complex. It doesn't have to be an integer or a float. So I can define my dictionary either element by element, or I can define it all in one swell foop like I did there. They're completely equivalent. And if I look at the dictionary, it'll get displayed out in that fashion. One thing you might notice is that here I defined it, both times I defined it with 2 as my third entry, 2 as a string, but it shows up last there. You should assume that the order that Python will give you keys is arbitrary. And if you want to deal with them in a specific order, you're going to have to figure out how to do that. Because things are stored however it's convenient for Python in a dictionary. There are a number of methods associated with methods or functions. We'll talk about why I'm using methods occasionally. That has to do with object orientation. And if you're not used to that, then that may be new to you. So keys for a dictionary gives us a list of what the key values are. Values gives us the values in exactly the same order. Items gives us back these things as pairs, as a list of tuples. Has key is a nice way to check if I have defined that key yet. And get is an even nicer routine. If I use get instead of just indexing the dictionary directly, then I can specify a default value if the element is not defined. And if I don't specify my second argument there, it defaults to none. So you could use a.get followed by a key, and you either get back none or you get back the value. So here's a more complete list of what's there and to use for dicts. Let's see. Sets. I happen to really like sets, and somebody actually even asked a question the first time I presented these slides that led right into this. A set is sort of like a list, except there's no ordering, and it only stores unique values. So here I've taken a list, which has got a bunch of duplications. That gives me the minimum set. The nice thing about sets is that you can do things like, if you want to know what's in, I've got two lists, for example, and I want to know what's in both of them. A very easy way to do that is to convert those two lists to a set, just like I did there, and ask for the union. Actually, I want to ask for and if I want to know what's in both. If I want to know if I want to get what's in either, I can use union. So union, here's and. So if I want to know how many elements are in my two sets, all I have to do is and them and count them. Okay, and if you want to get that back as a list, all you have to do is to take this gives me an output of a new set, and I just convert it back to a list. So you may not use this right away, but it's something that's worth keeping in the back of your mind, because sooner or later you'll come up with something where it's nice to have that. And we've shown this a couple times, but it's worth bringing home that length works with just about any kind of collection. It certainly works with any collection that's defined in basic Python. If you use somebody else's object and they didn't define what the length means, then it might not work, but it works almost everywhere. And length of a dictionary will tell you the number of keys or the number of values, so the same thing, or the number of characters and so on. Okay, so a bit of homework here. Read through those and figure out what the data types are. Okay, questions? All right. All right. So now that you've learned how to store stuff, you want to do something with it. So let's look at how we do expressions, and before that we'll talk about assignment in more detail. We saw how we do assignment. We assign something to a variable with equals, but there's more to it than that. Okay, so we'll talk about assignment and unassignment. We'll talk about expressions. We'll talk about a specific type of expression, which is a comparison. We'll cough, and then we'll talk about handling comments and continuations, because that sort of falls here if nowhere else. Okay, so we saw this. We assign a value to a variable with an equal sign. There's a tendency to think about this the way that C or Fortran might work, which is what happens when we do this in one of those languages. Some memory is set aside, and that value is put into that memory. That's not what Python does. What Python does is here we've created a data structure. And here we've made, and what we've done with the equal signs is we've put a reference to where that data structure lives into the variable. So those of you folks who've worked with pointers will understand that readily, that the variable is a pointer. If you're not comfortable with pointers, then you can think about it as a variable is a label that references something. One thing that you'll see when you start looking at other people's code is that you'll see this kind of weird statement here. This is called augmented assignment. You can take an operator, combine it with the equal sign, and what this does is this will just simply increment a by 1. You don't have to just do that. You can multiply by a value. You can subtract a value. You can do logical augmented assignments as well. Okay, why am I making such a big deal about assignment? Well, I should also point out one other thing you can do with assignment. You can assign to a tuple of variables. So here I have a relatively complicated tuple. It's a tuple of tuples. And if I do this, then the first value goes into A, the second value goes into B, third value goes into C. So as you can see, C ends up being a tuple, but the other ones end up being integers. This is a syntax that people use a lot, and typically people will write it without the parentheses. If you don't get the number of elements right, though, you get an error. So you can't use this syntax when you have a tuple that might vary, and it works just as well with lists as it does with tuples. Okay.
Danger, Will Robinson,
but
danger.
Here's where we have to be careful. Equals does not do what we're thinking it does because it's only making references. Okay? So here was here I've created a list, and I've decided I'm going to make a copy of my list. Okay? B is now equal to A. But it turns out I didn't make a copy of it. All I did was I've said B now points to the same list as A. And I can test for that. This is not something you'll use very often, but you can ask Python, where is this lie in memory? And if we do that, we find out that A and B are exactly the same location in memory. They didn't make a copy. And that matters because if I go through here, I look at the value of B, of the second element in B, is approximately pi. If I change that element in A, I change that element in B because they both point to the same thing. If I don't want that, I have to copy it. Okay? I can do that by using my indexing. You can also do it other ways, but that's a simple way to do it. So if I do this, B and A now point to different objects, and I can change one without changing the other. This probably won't bite you. Might, but it probably won't. What's more likely to bite you is that here, this list contains a bunch of different things that are constants, but this thing right here points to a variable. If I change the value inside here, then I change that potentially. So it doesn't work for constants. So here, C and D are the same thing, and if I looked at the memory locations, I'd see that C and D are the same location. But when I change C, I don't change D. Why is that? That looks a little strange. Well, the reason is that this creates a new data item. And I've said C is my new data item. I didn't change the data item that D points to. I can't. It's an immutable constant. Okay? That's one of the reasons why tuples and strings are immutable. So you don't change them by accident. So whenever you create a constant value, so whenever I create a value and stick it in a variable, it's going to be a new value by default. So where I can come up with trouble is here I'm making C a tuple that contains two things. It contains another tuple, and it contains a list. And I told you that I can't change tuples, right? Well, that's not completely true in the sense that if I want to index C sub 1, I'm pointing to B. So here I index C sub 1, that's B, and the first element in B, second element in B, I'm going to set to -1. So B has now been changed, and so has C. Okay? This is where Python can get really confusing. You think that you're making a new piece of data here, and you are, but that new data item has pointers to data items that exist elsewhere. Okay? However, here, now I have replaced the value of B with something new. C doesn't change because C is still referring to what was originally this data item. Okay, so this data item starts out as 3, 4. Here I change it to 3, -1. And here I overwrite B so that B points to something new. But C still points to the old thing. So be warned. Yes? Ah, yeah. but it's not. Okay, C is pointing to the location in memory where this thing is kept. Okay, and B is pointing to this thing. When I delete B, and I'll come back to this, but when I delete B, I've deleted a pointer. I didn't delete this if other things still use it. The way this works is that every data item has in it a counter that counts the number of references to it. And as long as there are references out there to a data item, it sticks around. As soon as the number of references goes to 0, then nobody can use it anymore, and it's eligible to be deleted or cleaned up. Doesn't mean that Python will do it right away for us, but it's eligible for it. So it might be deleted. So let me go just warn you that when Python does weird things and things change in ways that you didn't expect, you've probably been bitten by this feature of Python. And you might ask, why does Python do this? Why don't you just copy things automatically? Well, the answer is that Python's written in such a way that it can handle very, very large data objects. And you wouldn't want to copy a 100 megabyte image automatically every time you reference it. So if you want to make a new copy of it, so you can have one copy that's modified and one that's not, you have to explicitly say that. So that's why it works this way. Okay, and Jan just asked about unassignment. If you don't want something anymore, you just can say delete. What delete does is it deletes the variable name. Okay, my label A no longer exists. It doesn't delete the data item unless the data item is not referenced anymore. So here I created an object, I equated it, I put a new label on it, I deleted A. The value, the contents is still around. So this is telling you again, if you're working with that 100 megabyte image and you think you're deleting it, if you've got a reference to it somewhere in your code, it isn't going to get deleted. It's going to stick around. Yes, John? You don't. Not that I'm aware of. There may well be, but I'm not aware of it. I think, though, if you start needing it, that will sort of trigger it. But actually, I shouldn't say that. There is a way that you can, I think, force it. There's a new statement called with. I'm not going to talk about that, but I believe what with does is it creates a stack frame. And when the with block exits, it cleans up, I believe. But that may just force it. Still may not force garbage collection, but that's what it's supposed to do. And you had a question? Same one. Okay. How do I delete this? If I delete B, then it'll go away. Or if I put this inside a routine, if it's inside a function and it's a local variable, then it'll go away. Right, as long as you don't have anything referenced to it, the memory space is eligible for recovery. Garbage collection is the technical term. That would be a really dangerous thing for Python to allow you to do, because now you have references to them again. So I can't say the answer is no, because I don't know that, but I think so. I mean, in a sense, I don't know if you can reference something by its ID tag, but if you could save the ID tag and then get to it if it's still there. That would be really, really dangerous coding. Okay, so let's go on to expressions, because you really want to do stuff with Python, like add 2 plus 2. You want to perhaps multiply 2 variables. Here, just to show that I have made a dictionary where one value is 2 to the 10th and another value is 3 to the 10th. And I just wrote it that way so I could show you two different ways of showing exponentiation. And here's a really weird expression. What's 3 times spam? Well, if you look down here, you can see what 3 times spam is. It's spam, spam, spam. And since I included a space there, it's got spaces there. What's that? Indeed, indeed. What kind of what are you talking about? Ah, right, because what this, yes, that's worth mentioning. That's actually just a repeat of what I was warning you about before. When you multiply a list, you're not copying the list. You're just making a new list that contains references to the previous list. So if you change that list in one place, you change them in all. If you multiply a tuple, you won't get that. You can also take that and you can copy it. Do a deep copy, but yes. I wasn't going to try to give you an exhaustive list of expressions. You guys can find that for yourself, but here's a place to go look if you want it. Okay. Comparisons. You guys are very used to seeing this in lots of other languages. It's no different here, except perhaps that they don't necessarily need to be part of an if statement or something like that. It's just an expression. So I've asked, is 2 greater than or equal to 4? And the answer is false. Is 2 less than 4? The answer to that is true. You have the normal sorts of comparisons. Notice that if you want to test for equality, it's equals equals. One of the nice things about Python is you can't use equals where you want in a comparison. So Python will not allow you to do things that many other languages will do, where you can say, A equals B greater than or equal to C, or something like that, where you're doing assignment inside a comparison, and that way it catches a lot of the mistakes where you meant to type 2 equals. Okay, there's some special comparisons: in, not in, is, and is not. Is and is not are used to test object identity, which I won't talk about right now. But a simple example of that would be if you want to know if a variable is none, you might say variable is none or is not none, and that would tell you whether the variable is none or not. But it turns out you can also, at least in CPython, say variable equals none, and that works just as well. But in is really useful. In tests to see if something is matched inside a list, for example. So 2 in this list comes back true. 2 in this list comes back false because it only looks and it says this element is a tuple. That doesn't match 2. This one's 4. It doesn't match 2, so it's false. But I can test for, is this tuple in my list, and the answer is true. How about this one? This one looks really weird. I've written my tuple again, but this time I left out the parentheses, and I get something completely different. Why is that? Well, the reason is that this is my expression right there, starting after the comma. So that's no different from writing parenthesis around that. So I could have written this expression with the parenthesis around here, and then another set for the tuple. So this evaluates as false. Okay, so 2 comma false is that tuple. So be warned. Use parentheses where you think you need them. Okay, you can combine comparisons with and or, and again, using parentheses are a really good idea. because this gives me this, not that. Okay. All right. Comments. There are two ways it turns out to do comments, and they in practice they don't have any difference in the way you do coding, but they actually are used slightly differently. You can start a comment anywhere by preceding it with the pound sign. So I can put a comment on the end of this line here. If I have it inside a quoted string, it's not a comment, but after the quoted string it is. But another way that Python allows us to put in comments is just to define a string and then not do anything with it. If I define a string and I don't assign it to a variable, it's going to go away immediately. And it turns out that if you do that, if you create a string and you don't assign it to anything, that's something that Python says, gee, that must mean something. And that's called a doc string, or a documentation string. And this is very useful for developing well-commented routines. When we talk about how to write a function, I'll come back to that. But just recognize that if you type a string, you don't equate it to anything, you can then it becomes a comment. This makes it a nice way to comment out a whole bunch of lines of code. You put 3 quotes in where the first line is that you want to comment out. You put 3 quotes in later, and all that code is now a comment. Yes, John. Yeah. No. No. Well, wait a minute. Yeah, I should say be careful. Indentation does not matter for anything with a pound sign. So I can put that pound sign anywhere I want to on this line and it doesn't matter. It does matter for doc strings. We'll talk more about indentation, but I'll give you the answer to your question now. What about continuing lines? I showed you an example of this before, but I thought I'd spell it out clearly. Any of these open brackets, parentheses, square brackets, curly brackets, indicate effectively a block of code, because the line can't end until you get the closing bracket, whatever. So this makes a very easy way to write very long lines. There is a way to terminate line to make lines span multiple, to have long lines with backslashes. I mention that only because you may see it in code someday. My strong advice would be not to ever use it. I've never yet come to a case where I could not use at least parentheses to extend lines, and it makes it so much easier to read. Okay, so homework for this. I've got some simple expressions to try out, and a little bit of a question here about continuations. So those will be those. I think it's already on the web. Okay. So let's try one more module, and we'll quit. By the way, John, is this your coffee cup? Okay. All right. So let's look at some statement types, and this will actually leave you in a point where you can actually start using Python for a little bit of work. 3 kinds of statements, 2 having to do with looping, 1 for tests. Okay. So, if statement. We saw an if statement. I tried not to introduce statements before I use them, but I failed in a couple cases. Here's an if statement. And so I have if followed by a test. Doesn't have to be a test. Actually, I could just put a variable there. And if I put a variable there, I could even put just 1. And if what I put there is true or equivalent to true, then it will do the lines following that in the block. I need that colon there to indicate this is where the if statement test ends. Okay, how does Python know what lines are going to be used in this if statement? It looks at the indentation. And the first line following the if statement better be indented by at least one space relative to the one before it. And then every other line that is follows will be the same block if it has exactly the same indentation. So if this has 3 spaces and this one has 4, Python does not know what to do with this line, and it will give you an error. If this one has 4 spaces and this one has a tab, even though they line up in your editor perhaps, they won't line up as far as Python's concerned. This statement it recognizes as being not part of the block because it lines up with the if statement. Okay, if this has one extra space or one too few to line up with the if statement, again, I've got a syntax error, and Python will not accept that code. This is why it's so valuable to use an editor that parses out the Python and says, okay, I want all these lines to be the same until I get to the end of the block. If you are using a one-line if statement, so here I've got, I've only got one line in my block, I can say if a print true, and in that case you don't need to indent. The Python style guide says never to use it. I use it all the time. But again, the next line needs to line up with the beginning of the if statement. Let's see. If you put a variable here and it's not a Boolean, if it's an integer or a float, 0 is false, anything non-zero is true. If you put a string, list, tuple, many with the other data structure, if it's empty, it's false. Otherwise, it's true. And none is always false. So you can have an if statement that just simply says if var colon, and that's how it'll work. Okay. Obviously, you want to have a else possibility. So here's if test is true, else do this. So here, the number a is going to either be positive or it's going to be negative or 0. If you want to have multiple tests, you use the elif statement. So here I've broken this down into 3 cases: positive, negative, or 0. What if you want to put it together an if statement and you want to have one clause that doesn't have any lines in it? So I want to print if it's positive or 0, or I don't want to print anything if it's negative. There are other ways to do this. What if I want to do print if it's positive, 0, and maybe get around to later doing what I'm going to do if it's negative? You put in the pass statement. Pass, I guess, is analogous. It comes from bridge, that's my guess. It means just go on. So it's a placeholder. If I didn't have this statement here, Python would give me an error because it's looking for statements in this block right here. So pass is just creates a statement that you can put anywhere that does nothing. Let's see. Yes? It would be executed. Yep. Or a statement before it. Yeah. The pass just literally does nothing. The place, you could put it anywhere you want to, but the place where you need it is there. There's no other way to do it without putting in a statement there. Although I probably could put in our doc string there. That would probably work. I think that would work. Indentation really matters. The difference between these two sets of statements is the indentation associated with that else. Here, the else is lines up with the if. So this else is done if this isn't true. But here I've indented the else more, and it lines up with this statement, so it's done if B is not 0. Okay, that brings us to our next statement type. While. By the way, if anybody's interested, does Python have a switch statement? If you've used that in any other language, the answer is no. If you want to use if you want to do the equivalent of a switch, you just do it with a bunch of else ifs. Okay. Let's see. So here's a loop which will this while causes this block of statements to be done as long as this condition here is true. So I start out with t equals 0. Is t less than 10? The answer is yes. I increment t. You might ask, why didn't I do it this way? Because I didn't want you guys to get confused. And then I print it out. So this is going to start out, first number that will come through will be 1. The last time through, t will be 9. I increment it, I get 10. I print 10. And the next time through, t is now 10. So t is not less than 10. And it will just go on to the next statement after the while. So that's an easy way to loop. Okay? If I started out with t of 10 or greater, these statements would never run. Okay. What if you want to do effectively branching? Two ways to do that inside a while statement. If you have continue, that just means skip processing the loop from there and go back to the beginning. So what this will do is what we did before, except if t is 2 or t is 3. It'll skip the print statement. So this will print 1, and then the next number it'll print will be 4, because 2 and 3 will be skipped. No, continue is not like a break, because it's going to continue. Break is like a break, because break gets us out of the loop. Okay? So continue brings us back to the beginning of the loop. Whether it continues in the loop or not depends on whether the test is true. Yes, Mary? Okay. If I had a pass statement here, it would just go on and do the next line. Pass is a null op. It does not do anything. Okay? But continue says don't continue with anything else that's in here. Continue, go back to the beginning of the loop. So it eliminates printing this print statement. If I had a break here, which is the next example, when I hit t equals 2, I'm done with the loop. Okay? So here, I have a more complicated test, and this one will start when I get to, it will not get to t less than 10, because when t is 5, it terminates the loop. So this prints only up to 4. Okay. Now I'm going to introduce something that I don't know of any other language where this exists, but you can use else with a loop, which is sort of weird, and you'll find yourself really questioning the sanity of why they put this in the language until you start using it. What else does is the else clause gets done only when the loop terminates without a break. Okay? You can do this without doing that, but then you have to set some variables and tests up. This is a really compact way to do it, and it really makes it easy to read. Okay? So this loop here will get terminated if t gets to 10. But if the loop ends earlier than that, because s has terminated, because t is now equal to s, then it will print this. So this will print either from 1 to s or 1 to 9, whichever is smaller. But if it gets to 9, it also does this. It tells us s is less than 10, because it didn't execute the break statement. Okay? It's a little weird, but can make some sense. All right. For statement. The for statement works a lot like the while statement, except what it does is it takes a collection and it puts the values one at a time into a variable. Okay? So when I do this little bit of code, x will start being 2. Next time through the loop it'll be 4. Next time through the loop it'll be 6.0. And it'll print those out sequentially. And continue and break will just work the exact same way we did before, and for that matter, so does else. Let's see, let me just check what the next slide is. Okay, you can use loops with dictionaries. And if I define a dictionary and I loop over a dictionary, my variable here gets assigned to each key individually. What order? Well, arbitrary order, because as I said, there's no order to a dictionary. You'll get all the keys, but you won't necessarily get the order you want them. If you want them in a specific order, you better sort them or somehow manipulate that to get the order that you want. If I want to get the value, I just reference it that way. There are other ways to do to iterate through to loop through dicts, but I think this is good enough for right now. What about if you want to iterate through a couple lists at the same time? Well, turns out you can do that too, but we need a special function first to make our lives easier to do that. Oops, I lied. I'm going to do this slide first. What if you want to loop through a list of numbers? We generate that list of numbers with range. Okay? Range 5 gives us 5 values starting at 0. Range 2, 9 starts at 2 and gives us numbers up to but not including 9. Okay? We give range 2, 2. There's no numbers up to but not including 2, so it gives us a null range. We can also use a step. This is an integer function. If you want to use non-integer steps, that's a different function called xrange. But you can use a negative step if you want to. So that's an easy way to do a loop over a set of numbers. If you want to do a loop over over something more complicated, like a couple sets of lists or tuples, if I want to loop over A, B, and C and simultaneously over 11, 22, 23, and while at the same time maybe get some counting numbers in there, I can use this zip statement. But notice one thing. This is length 3, this is length 3, that's length 5. I only get something according to the shortest input list or tuple, and I get back a 3-element list, and it contains the first element from this, and this, then the second element from this, and then the third element from each. Once I've used zip, I can set 3 variables, because it's just like I have my equal sign where I used a tuple for 3 variables. So now I've set I, j, and k to I is going to be these, j is going to be these, and k is going to be these, but only up to the length of the shortest one. Okay? So if I had made this just a comma b, and then this loop would only iterate twice. So here I just showed you some code that allows you to figure out what it did if it wasn't obvious. Okay, a little bit of homework, and we're just about where I wanted to stop in terms of timing. You're ready to write a little short calculation. So compute n factorial, and if you don't know what n factorial is, I've written it out, where you use a while statement and do the same thing with a for statement, but and as a hint, use range.